Okay, we're back with this problem. Let's just finish up this way, and then I want to talk about a slightly different way, because this showed up in somehow how some people reasoned about this problem. Let me just. Oh, and what did I do here? I hope nobody just didn't go to the second installment. What did I do here? I didn't distribute a minus sign. Uh-oh. Now I'm going to FOIL this out. I'm going to get 4a plus 2 minus 2a squared minus a equals, let's see, that's going to simplify to minus 2a squared plus 3a plus 2. And then we're going to collect everything, and we're going to get, when we put it all on one side, we're going to get minus 3 minus 2 is minus 5. Minus a squared plus 2a squared is plus a squared minus a minus. Let me rewrite that in a standard order. And that's a minus 5. Now, it's a book problem, so this is not usually going to be so nice. But that's the numbers we get for a. So a equals 5, or a equals minus 1. And those would have been pretty good guesses. It wasn't. I didn't have the graph out far enough. What's wrong? To guess correctly that it was 5 up here, but it certainly looked like minus 1 was a pretty good bet here. Now again, when you get a random quadratic, you're usually going to get answers that are that nice. But since it's a book problem, they're kind of making it easy on us. So I want you to really think about the similarities between the forward version and the backwards version. It makes the backwards version, I think, look less intimidating and gives you some clues on how to do it. Let me just show you real quick a different backwards version. Or a different forwards version, okay? So we're still staring at this same problem, and we're saying, how do we start this? What would be an easier version of the problem to solve? Such a great problem-solving strategy. In the first forward version, I said, let's take a equals 3 and make sure it's really the tangent line, and then ask the yes or no question, does it go through this point? There's another one, which I think for some people is going to be simpler. Let's go ahead and just pick a point and draw the line between that and the known point 2 minus 3, and then ask, is that actually tangent to the curve? I think the algebra should work out a little simpler, in fact. So let's let a equals 3 and draw the line between 2 minus 3 and the point on y equals x squared plus x with a equals 3. Is it tangent to the curve? And if the answer happens to be yes, if we get lucky, then we're done. Now, of course, we know that the answer is not a equals 3, so it's not going to work, but let's see. So we're going to pretend we haven't done any of the other stuff for a sec. Okay, so if a equals 3, the y value that corresponds to that is a squared plus a is 12. So we're still interested in this point 312. That's definitely of interest. And then what we're going to do is we're going to say, how would we know whether that's tangent to the curve or not? It's all about whether it has the right slope. We've made sure it's a line through this point. So we're looking at this one right now. We made sure it's a line through the correct point. And if that happened to have the slope of the tangent line, then it would be tangent. We'd be done. So we just have to look at the derivative there and compare it. So first of all, let's find the slope. So the slope of this line, that isn't necessarily a tangent line, we just get by taking rise over run. 12 minus 3 over 3 minus 2. Well, that's 15. Okay, that doesn't look too good. That's a pretty high slope. So in 1 unit over, it went up from minus 3 to 12, 15 units. Okay, so that's why it says 15. And so the question is this the tangent slope at x equals 3? Well, we know that. Y prime of 3, again, was 2 times 3 plus 1 is 7. It's these same numbers coming in if you compare this to the previous version. But now we see those are not the same, so it doesn't work. So how can we convert that into a backwards version and use that to solve the original problem? Okay, let's see. So instead of plugging in a equals 3, we let a be a variable. So for any a, y is a squared plus a. So the point in question is a comma a squared plus a. Let me just sketch it again. You've got this parabola. Here we got this point, and we're constructing this line. We're intentionally constructing that line, not a tangent line right now. We're constructing that line, and then all we have to do is check its slope and compare it against the known slope of the tangent line, which we get from the derivative. So the slope of that line is a squared plus a minus 3, so plus 3, over a minus 2. That's the difference in the x values. And then we compare that to the slope. Okay, so that's the slope of the line, and the tangent slope is y prime of a. That's 2a plus 1. And we're going to get basically exactly the same kind of algebra at the end. You're going to get 2a plus 1. Is that equal to, or rather, we're going to set it equal, and then we're going to insist on it being equal, and we're going to find a. That's the difference between the forwards and the backwards problem. Before, we calculated this where a was equal to 3, and we said yes or no. Just thumbs up, thumbs down, and the answer was thumbs down. 15 was not equal to 7. Here, we're going to set them equal. We're going to say, no, a is a variable that I get to choose in the end, and I'm going to insist that these be equal. I'm going to insist that this should work out, so really, the picture is going to look like this. I'm looking for the magic a that makes it really work and makes it tangent. And if you solve this, I won't do it again, but I'll just show you. It's exactly the same. It's basically just the same equation. There's a few minus signs that got sort of switched around, but it's the same quadratic, and we still get a equals 5 minus 1. So depending on your preference, those are two different ways to set up this rather challenging problem. We're going to be doing a fair number of problems like this, which is why I wanted to spend some time on it. Thanks.